In this lecture, we're going to learn about controlled components. Controlled components are a design pattern for forms. In some situations, you may end up creating an input with special interactivity attached to it. You may want to reuse the input for other forms. This situation is where the controlled component design pattern may work for you. What exactly are controlled components? It's a component that outputs an input for a form. The input can be anything like a text box, checkbox, radio button, or anything else that can be used in a form. What sets it apart is that the component doesn't have its own state. It's not meant to be controlled from within. Instead, it relies on the parent component to supply it with data. The data from the parent component is what gets rendered as the value for the input. If the user attempts to change the input, the component will emit an event. The parent component will be able to update its state and pass down the changes to the child component. This pattern keeps the child component dependent on the parent component. This is why it's called a controlled component. It's a component that is controlled by the parent component. Let's look at an example. In the resource section of this lecture, I provide some starter files in a zip file. Take a moment to upload the files anywhere on your machine. Once you've got it installed, start the development server. Pause the video to get this ready. Here's what the project will look like when you open it in the browser. It's a simple form with two input fields. There's an input field for the name and another for the email. The name input is simple in nature. On the other hand, the email input is much more interactive. If we were to type into the input, the surrounding border changes to red. It's validating the input. The validation will be successful if the email is longer than 4 characters. We can type in 4 characters to see the border change to green. The form data doesn't get submitted to a backend. It'll get logged in the console. In the Chrome Developer Tools, we'll inspect the console. If we were to submit the form, the data gets logged. Let's open the application in the editor. I've added Bootstrap to help us with some styles. A lot of the files remain unchanged from the default setup. We'll be focusing on the app component. In this component, we have a lot of HTML and classes, but we won't have to worry about them. A lot of it is to mainly help us position the form. The form is where the magic is happening. On the form element, we're listening to the submit event. If it's triggered, we'll call a function called submit. Next, we have 2 input fields. The first input field has the vModel directive attached to it. It's bound to a property called newsletter name. The second input is bound to a property called newsletter email. In addition, the class attribute has property binding. We're using the object syntax to toggle 2 classes. They're the isValid and isInvalid classes. This will apply the green and red borders, respectively. The conditions we're using to check if the email's character length is equal to or greater than 4. If it is, we'll add the green border. Otherwise, it'll get the red border. Both conditions will check if the length is greater than 0 because we don't want to validate an empty input. In a real scenario, there are additional checks we'll want to perform. For demonstration purposes, we'll keep it simple by checking the length of the property. There's not much else to go over in the template. Scrolling down to the script block, we'll find the properties and methods that are used in the template. Initially, the newsletter name and newsletter email properties will be set to an empty string. In the methods option, we have the submit function. We're logging the properties in the console. The last thing we have is the style block. Instead of directly adding the styles, we're loading the Bootstrap styles using the source attribute. This is an alternative solution for loading CSS in a component. The source attribute can be set to a path for where the CSS for a component can be found. Alright, let's create a controlled component. We're going to convert the input for the email to a controlled component. An email is a common field for a lot of forms. It's perfectly reasonable to assume we'll need to validate an email in every situation. Therefore, we'll move the input into a separate component. We want the component to be reusable. In the components directory, create a file called emailinput.view. In the newly created component file, we'll scaffold the template and script blocks. The name option for the component will be set to email input. It's considered good practice to use multi-worded component names to prevent collisions with future HTML elements. Next, we'll move the input. Back in the app component file, we'll cut the input for the email. Paste this into the email input components template. The component will not work because the vModel directive is bound to a property called newsletter email. We'll define the data function for the component. We'll add a property called value. It'll be set to an empty string. The component we're creating will be used in multiple forms. The property name we were using previously is too specific. We want to treat the component as if it were generic. The property names in the component should be generic. We'll need to update the template to use the value property instead of the newsletter email property. The component is ready. The next step is to load the component in the app component. Back over to the app component, we'll import the email input component. We can register the component by adding the Components option. The last step is to use the component. In the template block, we'll load the email input component where we previously cut the input. We'll test the app in the browser. Back in the browser, we'll see the same input appear. We can begin typing in the input to check if it behaves the same way it did last time. The red border will appear if the email is less than 4 characters. It'll change to green once we meet the minimum threshold. That's great, but there is one problem. If we were to submit the form, the object in the console would still get logged. However, the property that holds the email remains an empty string even if the input has a value. This is because the component state is not accessible in the parent component. It doesn't send the data back to the parent component where the form submission occurs. This situation is where the controlled component design pattern can help us. To better understand what we'll want to do, let's explore the vModel directive. Back in the editor, we're using the vModel directive on the input for the name. The vModel directive is syntactic sugar. It does 2 things to an input. First, it binds a property to the input's value. Secondly, it listens for changes. Let's replicate the behavior of the vModel directive on the input. We'll replace the vModel directive with the value attribute. The value attribute is where we can set the value for the input. We'll bind it to the newsletter name property. View will update the value attribute whenever the property changes in the application. The vModel directive does another thing for us. If the user types in the input, it'll update the respective property bound to the input. We can replicate this behavior by listening to the input event. In the event, we'll update the newsletter name property to the event.target.value property. The code we've written to replace the vModel directive will do the same thing the vModel directive did for us. Let's try testing if this works. Back in the browser, switch to the View Developer Tools. We'll want to inspect the data for the app component. The value for the newsletter name property is an empty string. The input for the name reflects that. If we begin typing in the input, the component's data is reflected with those changes. It's reactive, the same as vice versa. We can use the tools to change the data in the component internally. Changing the data in the component will update the input. This is how the vModel directive works. The app component is controlling the input. In a way, it's a controlled component even though it's not wrapped in a component file. We're controlling the state of the input by using 2 directives. The way we're controlling it can be applied to our components. Back in the editor, we'll update how we're using the email input component in the app component. On the email input component, we'll add the vModel directive to it. We'll bind it to the newsletter email data property. The vModel directive doesn't need to be put on HTML form elements. We can use it on regular elements or custom components. If we use it on anything else besides a form input, the vModel directive will behave slightly differently. Make a copy of the email input component below. The vModel directive will bind a property called model value to the element we're adding it. The value for the property is bound to the value we passed into the vModel directive. In this example, it would be the newsletter email property. In addition, the vModel directive will listen to a different event for changing the property. It'll listen for an event called update:model value. In the event, it'll update the newsletter email property to the event object. Behind the scenes, these bindings are what the vModel directive will apply to our components. We can use this knowledge to update the behavior of the child component. We'll comment out the second copy of the component. The first one is simpler to read. Let's switch over to the email input component. We'll update it to use the bindings the vModel directive applies to it. The first thing we'll do is completely remove the data function from the component. We don't need to keep track of the value property in the data object anymore. It's going to be provided by the parent component. It'll be replaced with the props option where we'll accept the model value prop. In the template, we'll update the template to use the model value prop. This solution may work, but this will cause an issue. To understand why, let's go back to the browser to test if this works. By filling out the email input, Vue will throw an error at us. It's telling us we shouldn't mutate a prop because props are meant to be sent down from parent to child. The child component shouldn't be able to update the prop. It's a rule for using props. Let's go back to the editor. Back in the email input component, we can't use the vModel directive on the input because it'll attempt to change the prop. We'll replace it with the value attribute. We'll bind it to the model value prop. The binding will set the value attribute, but will not communicate the changes. However, we want to send the input to the parent component so that it can be stored for the form submission. We know that the parent component is listening for an event on the email input component called update:model_value. In this event, the vModel directive will update the property the child component is bound to. We need to emit this event if we want the data to be updated. We'll add the input event listener to the input element. If it's triggered, we'll call a function called update with the event object passed in. We'll define the methods option in the component with the update function. In the function, we'll call the this.emit function. The emit function allows us to emit an event programmatically. The parent component will be able to listen to the event. This is how we'll communicate the value to the parent. It has two arguments. The first is the name of the event. We'll emit the update model value event. The second argument is the data we'd like to provide. This argument is optional. We'll send the event.target.value property. We're emitting the value of the input. Here's a rundown of what's going on. The component doesn't have a state. It relies on the parent component to provide it with data. If the component experiences changes, it won't handle updating the data. Instead, it'll send the data back up to the parent component. The parent component is responsible for handling the data change. If the parent component decides to accept the changes, those changes will be sent back down to the child component. In this case, it would be the email input component. If the parent component rejects the changes, nothing will happen. Back over to the app component, we don't need to make adjustments to how we're writing the component because the vModel directive will handle everything. The child component must be updated to use the correct bindings and emit specific events. We're treating the component as if it were an input. We'll test this component in the browser. In the browser, try updating the input. According to the developer tools, the properties in the app component are updated whenever we update the input. Let's try submitting the form. Under the console panel, the object contains the value from the input. We've successfully created a controlled component. It's a component that outputs an input. It doesn't have its own state. Instead, the parent component supplies the state to the child component. A controlled component doesn't update its input. Instead, it tells the parent component when a change occurs. The parent component is responsible for updating the state. The controlled component design pattern is commonly used for form inputs that have special behavior attached to them. This behavior allows us to reuse the input in any form. The email input component is very generic. It isn't tied to the form. There's one last thing I want to go over before we end the lecture. We have the option of overriding the names in the controlled component. Back in the editor, we'll modify the email input component. We're using the name model value in the component. By default, we have to use these names. We can change the names by adding a directive argument to the vModel directive. Back in the app component, we'll add an argument called email to the vModel directive. The vModel directive will behave the same way as before. The main difference is that it'll use a different name for binding properties. Instead of using model value as the name, it'll use the name we added as an argument. The argument value can be any name we want. Let's update the child component to reflect these changes. In the email input component, we'll change the word model value to email. The purpose of doing this is to give us more flexibility and readability in our controlled components. The names are much more descriptive to the component, yet still broad enough to understand this component is not tied to a specific form. We can even add multiple vModel directives to a single component if we use the argument to change the default name used in components.